Hey, what's up, guys? This is Chung here. So this time, let's take a look at 1685, sum of absolute differences in a sorted array. Um, this one is a very interesting problem to me, at least. So you're given like an integer array nums sorted in non-decreasing order. Keep in mind, this is a sorted array. And you need to build a new array whose result I is equal to the summation of absolute differences between the nums I and all the other elements in the array. Okay, so in the other orders, so in other words, so you do a sum of this where you do a absolute difference with all the other elements. So for example, right, we have 2, 3, 5, and that the numbers the results of 0 is like of course there's always a 0, right? And then the second one is the diff with 2 minus 3 and then 2 minus 5, right? That's the absolute difference, and then so on and so forth. And then if we scroll down and we have this constraint, it's 10 to the power of 5, right? So I mean, of course, a brute force way is to what is to for each of the nums we compare, we calculate we summarize its absolute difference with every other numbers, and then we can get our answer. But it's a O n of n squared time solutions for that, and it will most likely TLE, right? And actually it will TLE. That's why we cannot use a naive brute force solutions. And how can we do it, right? I mean, a hint it will be a sorted array because when we use the brute force solutions, we're not utilizing this sorted array here, right? So I mean, if we how can we utilize that? I mean, and it's always like a good thing if you a good practice if you don't have any clue is try to draw some of the examples on the papers. So after drawing some examples on the papers, I think something or a pattern will emerge because by looking at the problem, sometimes it's always hard to find the patterns where you can utilize. So let's take this example 2 here, right? And we have 1, 4, 6, 8, and 10. And let's try to calculate the nums I for this 4 here. Let's say this is I. So what do we have? We have 4 and 1, right? Since now I think it's kind of obvious, since we know it's sorted, when we calculate difference from 4 to 1, right? If we do a 1 minus 4, right, and we do an absolute value, since we know 1 is smaller than 4, so we are sure that we can write the first number to 1 to 4 minus 1. That's going to be our first numbers. The second one is of course it's the 4 minus 4. Doesn't really matter which one comes to first because it will be 0. And then the third one will be what? If we do since anything that's after 4, right? That's gonna be greater than 4. So which means that to calculate the absolute difference for those numbers, we do a 6 minus 4, right? Plus 8 minus 4 plus 10 minus 4. Okay. So now something has happened. Some patterns has appeared. So what is the pattern? So we have what? We have 4 times 2 or 2 times 4. 2 times 4 minus what? Minus this 1 plus 4. So this is the first part. That's basically I'm including this 4 to the first part. And the second part is this. Second part is this is 6 plus 8 plus 10 minus what? Minus 3 times 4. So what do we have? We have a prefix sum and the suffix sum, right? So the prefix sum is 1 plus 4, which is the prefix sum until I, and the second part actually is the total sum minus the prefix sum, right? This is the remaining sum of this array here. And we have and then we have what? We have the number of the fours we are going to multiply first, and then we minus the prefix sum, prefix sum, and the second part is the remaining sum minus subtract the numbers of 4 that's gonna be the remaining parts of the numbers of 4. So, and here we have a formula, right? So we're at this kind of I here. We have like this. It's I plus 1 because that's the length, right? So we have a I plus 1 times 4, right? Minus presum minus what? Minus so this part is what? It's a total minus presum, right? And then we subtract what? Subtract so here we have a n minus I minus 1 and times 4. And this is going to be our formula to calculate for each of the numbers. And as you can see, if we do a presum, and then this is going to be, and we do a total in advance, so this part is going to be O1. And that's how we solve this problem in O of n time. And once you have this, the formula, and everything should be pretty straightforward, right? And actually, so all we need is like this. We need a total equals the sum of the nums, sorry, the sum of the nums. And then we have a length of the nums, right? And then to do the pre-sums, I just use the running sum, right? I think that's easy to use. And then we have an answer, right? We have answer equals to empty list at the beginning, and then we have 4I nums in enumerate nums, right? And then first thing first, let's calculate the running sum for the current I. Now the answer, right? The answer is what? So we do answer dot append, right? We can write those formulas inside this append method. So the first thing is num times, we have that's first thing is I plus 1 times minus, right? We have this 1, 4, 6, 8, 10, right? So here, that's the I, right? So we have this minus running sum. So this is the first part. The second part is like this total minus running sum, right? And then we minus the n minus I minus 1 times num. Yeah, I'm just basically writing the formulas here, and then that's it. So if I run the code, that's it, and submit. Yeah, there you go. So there you have it. All right. So and yeah, and then it's O of n time complexity. Yeah. So it's not that hard, but I think it's a very interesting math problem, and with some of the observations and with some of the paperwork. So I think you have to write I actually write down some calculations and some examples here, then before finding this formula. And yeah, I think that's it for this problem. And thank you so much for watching the video, guys. Stay tuned. See you guys soon. Bye bye.